TypeScript unions are distributive. What? I have prepared a nice type called some garbage, and as the name suggests, it includes a little bit of this, a little bit of that, strings, numbers, booleans, undefined, whatever. And what I want to do is illustrate some operations on types that will show how do unions distribute under certain operations. So let's start with filtering only the string values out from the some garbage type. So one way to do it is to run some garbage and make an intersection of the type with string values. So what you could think of, and obviously this is going to be just the yes and no, so numerical, boolean, undefined, and basically all non-string values are removed from the type. So what you could think of is that TypeScript basically grabs the whole union and makes an intersection with string as a whole. So this is not necessarily true. What TypeScript is doing instead is it's taking the union and it's breaking it into smaller pieces in a way that all the members of the union are going to be taken with the intersection with a string. So let's just illustrate the step number 1. And the small results of each of these steps, of each of these operations, are going to be applied into each of these members separately. And we will see what this brings us. So this is step number 1. And now we can see that yes and string basically boils down to yes, no and string boils down to no. 0 ampersand string is obviously an empty type because there is no intersection between a number and a string, so that boils down to never. 1 and string boils down to never, and same with the other one, so these reduce down to an empty result. And if we grab all these small elements and form a union back, what we get is union of yes, no, never, 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 and never. So all in all, what we've got here is going to be a union of yes and no. And that's basically how TypeScript performs an operation not on a union as a whole, but it distributes the union into smaller, basically atomic members of the union, and then having a bunch of results, it merges the union back. So it doesn't only happen when we run it with an intersection, it also happens when we run, for instance, conditional types, or when we perform lookup types and probably some other operations as well. So let's take a look at another approach to filter out string values, which is going to use the extract conditional type. So from the elements of T, we want to extract only the elements which are also included within U. So from the some garbage type, we want to filter out only the strings. Again, the result is going to be the same. So this is going to be yes and no. And the same way, in this case, it's actually something common for conditional types, is that on the left-hand side, we're passing some garbage, as we can see here. But the thing is, here we've got a whole union, but when we actually apply the t-type parameter here, the union is not here anymore. This is only a member of the union. So you could say that on the left-hand side we've got a union, and here goes the distribution, and on the right-hand side we've only have a member. So T extends U of type either T result type or never. What we would get is basically taking, let's use the thing that we've got from the previous one. So we're going to apply yes over what we're trying to filter out. So that would be string, and if that's true, then we got yes, otherwise never. So does yes extend string? So is yes a subtype of string? Of course. So what we get is yes. Again, here I'm just going to simplify it. So from no, obviously we get no. From 0, does 0 extend string? Obviously no. So we get a never, because we walk into the else branch of the conditional. Now, for 1, does 1 extend string? No. Does true extend string? No. So we get never each time. Does false extend string? No. Does undefined extend string? No. So we get yes, no, never, 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 never. So the result is back again the same. So one more example of how do TypeScript types gets distributed. So I have slightly more intelligent example. We've got a car object type and a truck object type. We've got a brand, which is Audi, and a brand Volvo for the truck type. So when we want to take a look, what is the brand of either the car or a truck, then, oh, by the way, we can also do the type union, which is going to be a union of car and truck. Obviously, both brand and model properties exist on both, so we can access both. And when we want to take a look at what is actually the value of brand, we'll see that depending whether we are in car or truck, we would get either value of one of the members or the other. Again, when TypeScript tries to walk into a type of a property, it doesn't do it on the union as a whole, but instead it's trying to, so when we're trying to run union of a brand, what is going on actually is that TypeScript would try to break the union again into each member and try to apply this operation on each of the members and then merge the result back together into a resulting union. So car of brand, in our case, this is Audi, and truck of brand, in our case, this is Volvo. And in many cases, what you should be aware of is that when applying either intersection or conditional types or lookup types, something that happens underneath is that you are not treating a union as a whole, but instead, TypeScript is running an operation over a member. How do we know this? Well, it's actually pretty simple. Let's take a look at conditional types, for instance. So, does some garbage as a whole extend string? Obviously no, because when something extends as string, it basically means that it could be a subtype, something more specialized. So, does yes and no extend string? Yes, because these are just subtypes of a string. But could 0 and 1, which are also members of some garbage, do they extend string? No. So that should be basically never. If it was taken as a whole, that should be never.